So the solution to this problem, or one of the ways to solve it, there are multiple, is using this equation involving the energy principle. It says that the change in kinetic energy equals the negative change in the potential energy plus work done by non-conservative forces. And the force that we're worried about in this problem, friction, is a non-conservative force. So we can use this equation. So we have to first calculate the components of this equation. I started out with potential energy. In this case, that is gravitational potential energy. So you have to find the height of the box, the starting height of the box, which we're not given. But we know the ramp is 1 meter long, and we know it's a 30-degree incline, and we know it starts at the top. So we can use trigonometry to say the sine of 30 degrees equals the opposite of their hypotenuse. The question mark is the opposite. So we can simplify this to the unknown side equals the sine of 30 degrees. So sine of 30 degrees represents the length of this side right here. So now we know when it's at the bottom of the ramp, U final, we know U final is equal to 0 because it has no height. So we can say that -3, which is the mass, times 9.8. This is just the equation mgh for the gravitational potential energy. So we take the mass, which is 3 kilograms, times 9.8, times sine 30, which is the height of the box initially. And that's going to be our delta U, because U final equals 0. Now, moving on to K, we know that at the beginning the box is at rest, and we're trying to find the final kinetic energy, so we can use that to find the final velocity. So we'll just say that X represents our unknown final kinetic energy, and 0 is our initial kinetic energy because the box is at rest, and kinetic energy is energy from motion, and it doesn't have any energy from motion. Okay. And then for our work by non-conservative forces, the equation for work is force times distance. If we're being precise, dotted with distance, but you don't need to know that. Times the cosine of the angle between the displacement vector. So the box is going in this direction, and the force applied, is going in the opposite direction. So the angle between them that's a horrible theta, but the angle between them is 180 degrees, which just equals -1. So that's just a fancy way of saying friction force is doing negative work on the box. So you come out to this 5 newtons of frictional force for 1 meter in the opposite direction of the force. And then that comes out to -5. So this right here is just me plugging it into this equation. So we have that X, which is what we got for our delta K, minus this value, which just makes it positive. So X equals that value minus work done by non-conservative forces. And the reason it's minus is because of this cosine 180 makes it negative. So we solve for X, which X, as we know that K initial equals 0, we can just say that delta K is the same thing as KF. So KF equals this, and then this is the equation for kinetic energy, and we can use it to find the final velocity.